Hello, this is Postgres FM. As usual, I don't remember the episode number.
137?
137. My name is Nikolay, Postgres AI, and as usual, my co-host is Michael, PG Master. Hi, Michael, how are you doing today?
Hello, Nikolay. I am good, thank you. How are you doing?
Fantastic, honestly.
Good.
A lot of things are happening, but all good. I mean, like, things are changing, and a lot of things are changing in a constructive way, which I like. So, yeah, let's discuss Gin. It's one of things a lot of folks use, and a lot of, like, it's one of index types many people use still, and I think it's not going to disappear despite the rise of vector-related types of indexes and approximate k nearest neighbors indexes, right? Gin is very interesting type of index developed by the same folks who brought wall support to Gist, right? Gist was like the only thing for complex data types before Gin, but then with rise of JSON and JSON-B, Gin became very popular, finding a lot of applications. Not only full text search, as it was, I think originally it was created for full text search.
Yeah.
Yeah. So
yeah, I looked at the history. I was shocked to see that it was added back in 8.2, so 2006, nearly 20 years ago.
Yeah, this is exactly when I started to be involved with Postgres.
Yeah.
And 8.2 when I worked on XML as well, and I thought how to provide good indexing capabilities for XML, but it was too big task for me, being like too young guy. But we discussed with people who worked on Gin these ideas, of course, and of course I miss those days, and I feel sad, very sad about what's happening in the world and how disconnected we became, all of us. Yeah.
Because these guys are all Russian folks, but also I was looking at the domains, and one of the there's an article mentioned in the Postgres docs on Gin indexes that references the initial release and mentions who sponsored the work, which I think was a German company. But one of the domain it's hosted on is .su, which I didn't even know what that stood for. It turns out it's USSR or Soviet Union, which makes sense.
Yeah, I wanted to say that originally the primary purpose was to support better performance for full text search, and originally full text search was powered by Gist, and its version called RD3, Russian Doll 3, where its B-tree-like structure was created for basically arrays, for sets, and supported operations like instead of less than, greater than, supported operations contained, one array is contained in another, or contains, right? So, or also overlaps, and Gist can work with this. It can support full text search, but it's slow if you have large volumes of data and a lot of words, different words, like the vocabulary is huge, actually used vocabulary, right? So Gin is inverted index, and the name was inherited from Gist. Gist is generalized search tree. I like this so much. Folks who are interested in databases and want to learn something cool, read article by Hellerstein from Berkeley, Joseph Hellerstein, and the article about jumping from single dimension B-tree to two-dimensional space R3, and then generalizing this idea to Gist, generalized search tree. It's so cool. Like, and then additionally RD3, it's for sets already. And of course you can have multiple dimensions, like many dimensions. Not so many as for vectors, unfortunately, like not 2000, but for a few dimensions, Gist works well. And even there was a history for R3, original implementation of R3, native implementation. Gist behaved much better, so it was replaced. Original implementation of R3 for multiple dimensions was replaced by Gist, not for B3. But there is extension, Gist B3 for various like multi-column indexes and so on, when you have columns of different nature. And trees are great, but for full text search they are not so great. So they jumped from idea of working with trees to inverted index, which is more common idea for search engines. And compared to tree-like structure, inverted index is very very simple. Explanation can be, okay, we have list of words, and for each word we have list of references to places where this word was noticed, right? Like
rows.
Links to tuples, not row versions.
Yeah.
So list of words, of course normalized, and then for each word list of places where it can be found. It's very, very similar to index in a book, in the end of the book.
Yeah. I read this, and for so many years I've been using and reading about, indexes at the back of books, or in recipe books is a really famous example, a really easy one to understand how indexing speeds things up. But it never occurred to me that they're not a B-tree structure; they are a list of words.
Mm-hmm.
Yeah, exactly. It's an inverted index. So yeah, and I think the thing that clicked for me as to why the word inverted is used was in a standard, in a non-inverted index, we have an entry per row or row version, and in an inverted one, each row could be referenced multiple times, assuming
exactly.
In a full text search case, for example, each document is likely to have lots of words in it. So that's where the word inverted comes from.
Yeah, in tree-like structure, in tree, in B tree, R tree, RD tree, in gist in general, we perform descending. We say we need to find this value, for example, and we jump from one node to another, down to the index, towards leaf nodes, right? Leaves, performing some operations to understand where to go, in which child node to choose. Not only direction, because it's each internal node might have many children, unlike binary tree. And my favorite example, favorite question when hiring engineer, not database engineer. For database engineer, this question is mandatory. But software engineer, backend engineer, you can ask what is B tree, and if you hear binary, this is game over for. And this, unfortunately, I had situations when very, very good software engineers, I had this feeling, do I want to ask that question? And because it's like kind of flipping the coin, and then I hear binary, and my internal principles say this is no go. So yeah, so B3 is not binary tree. B3, unlike binary, we are only 2 children in its maximum. We have many children for each internal node, maintaining some rules.
In case anybody's wondering, balanced.
Well, there are several theories about it, as I remember, but I don't remember theories. But okay, yeah, balanced, but actually it's almost balanced, meaning that, conceptually, the path from the root to each leaf can be n or n plus 1. This helps with balancing. So almost balanced. Okay, when we work with tree, we have several operations until we reach leaf, and leaf has pointer to the tuple we are looking for. Inverted index, okay, we find our word, and then we find many places for this word, right? And this also means there are several challenges here. I remember originally, as I understand, maybe my perception might be wrong, but it was long ago. How many? 20 years, right? Almost. I remember Gene was lacking some internal B3 indexes. It needs B3 indexes twice. First, to find the word, because if the number of different words is huge, we need additional mechanism to perform the search faster, and it can be B3, right? And second, inside posting lists, we also have B3s. So inside Gin, there are two types of B3 indexes, as I remember. And I saw Igor Rogov's articles and book about internals, and this book has, of course, whole section about Gin indexes, and I saw a representation, visualization for Gin was, I think actually documentation also should have it, right? It's one of the, maybe the first illustration which was added to Postgres documentation was Gin, if I'm not mistaken. My memory might trick me a little bit, but I remember I saw it was 90 degrees rotated, so instead of like in book we have words and then we see page numbers to the right for each word. It was rotated 90 degrees, so everything looks down. So it seems like we going down all the time, like in case of gist or B3. So starting from search of our word, then we using internal B3, then we go in posting list. We also use B3 and also descending, right? And I honestly feel confusion. I like the book-like visualization because it adds it distinguishes from tree structures, and also we have three internal trees here, and it only adds confusion in my opinion. But well, this is the choice. I think the guys who created visualization and wrote, and Igor Rogov and others, they are great in terms of education, and I definitely admire them, their work in education. So, but I personally like original representation. We could write B3 also rotated, highlighting that it's kind of different beast in terms of indexes, right?
Yeah.
Good. Yeah. This is sorry. This was my introduction, just like history and so on, and some simple explanation. Yeah,
I really liked it, and I really want to like diagrams in the docs. I think a lot of effort goes into making diagrams that are easy to understand. Unfortunately, we don't have that many in the Postgres documentation, but I also find that I don't learn best visually, I don't think. And I found the description in the Postgres docs of how Gin works particularly useful. It's really well written, like most of the documentation, but I found that really helpful. So I'll link to that in the show notes as well. I think that's an incredibly good description with a few examples of, I mean, obviously full text search is the main use case, but it's not the only.
I think right now, full text search was original main use case. Right now, main use case is JSON-B.
Yeah, interesting. Well, I don't see that. I'd say, I'd be interested in the results of your poll. I think you've put a poll on Twitter, but I do think Gin is probably the second most popular index type
after
I see.
B3.
After B3, but it's by somewhere in the region. I was thinking order of magnitude wise. I'd say there's fewer than 1 in 10, maybe, but probably more than 1 in 100. So like somewhere in between those. So it's still not super common for me to see them.
Yeah, almost half of folks voted. They say two index types they use, and I guess it's either B3 and Gin, or B3 and vector types like HNSW.
Interesting.
Could be. Who knows?
I do see the occasional Brin and the occasional hash, but often those are kind of people have left them lying around after an experiment, after like trying them out, but not necessarily getting that much usage.
Postgres should add telemetry enabled by default. I'm joking. To get usage stats.
Well, actually, I know this is a real tangent now, but I do think that the usage stats can be misleading for people as well, because the last person I came across that had a hash index, they had a hash index on the same column they had a regular B-tree index on. And I said, that's redundant. Like if you could, the B-tree could
you already pay the price for maintaining B3, so.
Exactly. But the hash index was still getting used because it's a bit smaller for that. So it was still getting usage in the telemetry.
We had an episode about hash indexes, remember?
Yeah. All I mean is the telemetry isn't enough to know that you can drop that hash index because it's still getting usage.
I'm joking about telemetry. I cannot imagine Postgres would add some telemetry stuff enabled by default. It's like it's completely opposite to what it's usually done in Postgres. So, but I'm very curious, of course. I think big platforms might have some stats, but who knows? Anyway, like it definitely looks like B3 is number one, but just Gin maybe number 2 or number 3. Right?
Oh, sorry. I understand what you mean by telemetry. I thought you meant like for the users to see what they were using.
No, imagine Postgres has telemetry sending to some server all usage of.
The cloud providers could do it. Like,
yeah, exactly.
Anonymized. Yeah.
If they can, because it's also a question how much they can go to schema analysis. Usually it should be possible, but yeah. Okay, but it's better to focus on different tasks for cloud providers, and we can discuss this another time. This is not number one priority, I'm pretty sure.
No.
So, okay.
How about you? What do you see? Like, how often do you see Gin being used in the wild?
Well, it's used for full text search, but often it's losing to Elastic in larger companies. In smaller projects, it's great, but in larger companies, we should discuss performance gains and overhead next, right? But
yeah,
what I see, it's great until it's not in terms of full text search. For JSONB, kind of similar, but there we can tune it, right? We can use smaller size of index, just preserving only information about keys and values. JSONB, pattern ops, these things like additional, you can tweak it, right? And
yeah, path ops maybe.
Path ops, exactly. Yeah, JSONB path ops. So you can say I don't need everything to be indexed, all the knowledge about structure. I just need keys and values, and support only part of operations, search operations I have. And for JSONB, for sure, I see it. But at the same time, in many cases, JSON or JSONB values left unindexed because it's just storage for some metadata, for example, and we don't need to search in it. Or we decide to search only using specific paths inside JSON value. And then in this case, for both JSON and JSONB, and even for XML data type, you can have B3 because it becomes a scalar value when you apply some, like you need to get the value from some path. That's it.
It's just an expression index. Yeah,
exactly. So I also see quite a lot trigram, PGTRGM being used with sometimes with some issues, but yeah, this I see as well. Yeah.
So again, normally related to full text search, right? For I say trigram, by the way, and I thought maybe it's trigram. I don't know.
I think JSONB is number one in my head. It's so I don't have analytics. It's some subjective perception.
Well, it makes sense, right? It makes sense if you think I might want to do some search on this. It's a perfect. It came 10 years before JSONB, but it's the perfect index type for it. If you don't know in advance what you're going to want to be searching for.
There is also a full text search for JSONB additionally, right? Specific case. So I remember some support was added to perform full text search inside JSONB values, also powered by Gin, I guess, right? So anyway, like this index is great. Well, for arrays as well. I use it many times for arrays. If I know I need to store arrays, text arrays, number like integer arrays, doesn't matter. I like how Postgres supports them for decades. Array support in Postgres is great, except one thing, you know it, right?
Nulls?
No. Similar, but no.
I don't know it. No.
It's indexes. It starts with 1. It's very confusing.
Oh, okay.
Super confusing.
You confused me saying indexes. I was thinking.
No. Yeah, it's different.
Index structures. Yeah.
It's. To access the first element, everywhere else.
0, right?
Outside Postgres, it's 0, right? But in Postgres, it's 1, and you need to switch your mind all the time. Not everywhere else, but yeah. And for arrays, it's great. For example, I remember my very first talk in the US in 2008 was about how cool Postgres is for Web 2.0. And I talked about EAV structure, how like it's performance-wise not good for larger data volumes. And when we talked, like I talked about tags, right? For social media, we need tags. And putting tags into separate tables following EAV, entity attribute value structure, is going to hit performance. So instead, we can put it as arrays in the same table. And then to search, we can just use Gin, right? And Russian doll tree will be effectively used, but supported by Gin implicitly, right? So in this case, you can find quickly, like, give me rows where we have this tag, right? There will be problem, although, of ordering, right? This is before we move on to discussing this problem, I think this is the biggest problem with full text search and general Gin. People suffer from it, but we will discuss it. Before that, let's discuss performance gains and losses. Gain is obvious. Search speed is much better for inverted index than for tree-like structure. So for larger volumes of data, search is good, select is good, right? If one comment here, only if we talk about the use of Gin only, right? And
so like only searching by one dimension.
Well, one word or few words. Also, it has internal kind of additional internal query language. You can say and or phrase search. A lot of features there. But also, when we say this, search speed is better, we need to think about edge cases as well. For example, if we have very, very popular word which was not excluded by putting it to stop list or vocabulary, stop list dictionary. If we didn't put it there, we're going to have poor selectivity and high cardinality of result set. And performance, I don't know, limit works, right? But then there are edge cases when it's quite popular word, we use Gin, and there is a big problem of the need to combine Gin-based search with something else, like, for example, additional filter on some Scholar, like timestamp or anything, or ordering, right? And this is a huge problem. Like, I want to find everything which includes these words or these values, doesn't matter. But I also need to get 25 last items from there. And this is huge.
Or somehow weight it. Like you might want to weight based on the more recent, the more you want to weight it. But if it's got, the word many times over, I get it. I think we're probably venturing a bit too far into full text search stuff rather than Gin stuff, but you're right. And
it's about Gin. It's not about full text search. For trigrams, don't you want to have most popular used or like the latest? Or for JSON-B search, I want to find everything which includes these things, but I want very fresh. I want to order somehow. And in most cases in modern world, like when it was created, the idea was we are going to order by ranking. It was full text search, right? Ranking, like most relevant. But in social media, usually don't want that. We usually want the freshest information, like fresh.
Yeah.
So creation time or ID, if it's numeric, or UID version 7 would work. So we need to order by some Scholar. And this works not well with Gin.
I think you're right, though. I think maybe at scale it's always going to be a problem. There is a feature that was added from the beginning with Gin, to at least for the stop word issue, and that's Gin fuzzy search limit that you can set in. That it recommends in the thousands, so that if your search would have returned more than that number roughly, it will limit them, but it will limit them randomly. So that plays into your which one should be returned. But the idea behind that feature is if you're returning thousands of options anyway, how good is that search in the first place? Like so You're right.
Also, statistics-related work, like over time, it was improved, but I remember still having issues like with lossiness of for a planner, right? Like we need to recheck. I don't know actually details right now. I'm using Gin blindly lately in terms of performance. But for me, the key problem is inability for Gin to combine search with additional Scholar-based filters or ordering. Ordering is number one problem for me. It led the same folks to create RAM indexes.
Yeah, which confused me because when they launched gin, they said you should think of it as a genie, not as an alcoholic drink. But then they come out with rum, and it's definitely about alcoholic drinks. So I don't believe them. Yeah,
ambush, right? So yeah. Well, and rum, unfortunately, in my case, it didn't work well because of like it was huge and so on. Maybe it was because I tried to put the idea of rum is let's put scholars into a structure, right? Like timestamp.
So that you can do the
creation
so that you
time.
can do the thing you wanted.
Right, exactly. And creation time, it's how many? 8 bytes or 16? I keep forgetting. It was huge. I guess I could reduce it. For example, putting 4-byte integers just to support ordering. There are ideas how to improve, but still, this is an extension. It's not available on many platforms, unfortunately. But there is another thing. There is a standard contrib module extension which is available everywhere called Bitregin.
Yeah.
At least this can help you to combine different filters. For example, if you want to have filter to search in JSONB or full text search or trigram index, you want to combine it with additional filtering, for example, like price, right? Or age, depending on data, right? This is possible. This is worth considering. So to have multi-column index and maybe for all ordering, it also can be helpful. But if you don't do anything, what is usually happening, planner needs to decide. Should it use, for example, primary key to order or create an add timestamp to order by, and then apply filter on, instead of Gin, it will be just applying filter for whole data it will found. It will find. And it can be very, it's like, alternative is to perform Gin filtering, find everything, and then sort in memory. And it's hit and miss. Sometimes we see that planner is very optimistic, thinking we will quickly find just following B3 by created add in reverse order, like very fresh item, dynamically check, does it match our filter which is supposed to go through Gin? Well, it's not matching. And if it's a miss, it might like skip many rows until it finds our 25 target rows. And just following B3, not involving Gin at all. And this is a terrible situation. I saw many incidents because of that. So, or vice versa, Gin, again, we use some popular word, it finds millions of entries, then tries to like sort them in memory to find top 25. Maybe it's like edge cases here maybe hitting less in terms of performance, but also not fun at all to have this situation, right?
Yeah.
And this is number one problem.
It could be where the fuzzy limit could actually maybe help there, depending on how important it is to not have false negative, like things that should show up not showing up, I guess, depending on the use case. If you just want to show let's say you're showing a social media feed, trying to show engaging things to people, it doesn't matter if there's a few really good ones that don't show. But then if you've got a different use case, then it matters a lot. Like if for full text search, if you don't show the most relevant thing, that's an issue.
Or for example, user just added something, goes to search, expects this to be there, but it's not there. It's not good. It's like it's feeling of this is like it's a bug. So in many cases it's unacceptable, unfortunately. And also there is a problem with pending list, right? Pending list. So
this is about inserts rather than selects.
Yeah, not posting lists. There are posting lists for each word. Basically, we have references to tuples. It's posting list, and then there is pending list, which was like the trick to. We forgot to mention the main problem with Gin. Actually, the key problem is slow writes, right? because search is fast with all the things we discussed, but writes are slower than writes to tree-like structures, to trees, to B-tree, to gist. So even with rebalancing, I guess it's like slower. And what was created? Fast update option.
It's an unfair comparison, right? Like, it's almost by design that they have to be slower because documents contain lots of words. One row being updated or added creates multiple writes to the index. So it's not a fair fight. It's not a fair comparison.
I agree. So to mitigate this, fast update technique was created, and there's an option fast update when you create an index, and I guess it's on by default, right?
Yeah.
Yeah. So fast update means that changes will go to some temporary like buffer, like kind of location inside the structure called
pending list.
Pending list, yes. And then at some point when they reach by default 4 megabyte.
Yeah, there's a few things that can trigger it. That's one. There's like a catch
what
there.
Happens?
But also it batch processes them, right?
Yeah. And it's happening. It can happen synchronously. So some write, some update or insert might suddenly be very slow. So slow it might hit like your statement timeout, which is like 30 seconds, for example, or 60, depending, right? Or 10 seconds. And this is like unpredictable performance for writes.
Yeah.
Or Vacuum can do it asynchronously. Vacuum I like, but what I saw from practice, Vacuum is good, mitigates this, and not allowing this job to be done in a synchronous manner. But it works only if our duration of Vacuum is reasonable, which points to the direction we do need partitioning. Because if we have huge table, Vacuum is super slow, it cannot catch up with our writes, and pending list problem hits our writes. Users notice it. At some point, it might be so that we decide, okay, we need to switch off fast update for some indexes, for large tables, because we want predictable, maybe not good, but predictable performance of writes. It depends. There is a trade-off, and I see both cases are not ideal, like if you have really large volumes of data and workload, heavy workload. So partitioning can help here and to keep fast update on, in my opinion.
Well, yeah, have you tried it? I'm just thinking, actually, then you've got to have the partition key in the query, and then suddenly you've got another dimension there. Sounds tricky.
And so what? We need different index in this case, right?
Well, it just might not then use the GIN. I've had trouble convincing the planner to use GIN indexes in the past when they've got another choice, and it doesn't. I'm probably doing. Maybe I'm doing something wrong, but I wanted to try and get a bitmap scan, like anding the index, like with a GIN index as one bitmap index scan, and let's say a B-tree index is another.
Sounds like the case for B-tree GIN for me.
Well, a multi-column GIN index with B-tree in it could have helped, but it wouldn't have been structured quite as optimally, in my opinion. So I was hoping to get this and list really short and then a really quick scan. And I didn't have luck with multi-column GIN index being as performant as I thought we could get it with a bitmap scan. But that the partitioning thing, I would love to be wrong, but the partitioning thing sounds like you've now got a GIN index per partition, right? So you've got to get to the right partition. So then it's like, I get if it's time-based,
partition pruning should work. Partition pruning should be in good shape, of course, but this is general rule for partitioning.
Yeah, but so let's say you're partitioning by time. It means we've got the time filter on, right?
Right.
Is that the case when for full text search, for example? Are we going to be filtering by time?
Well, if we're ordering by time, as for social media, again, we need fresh information. In most cases, this is the rule compared to previous era for Web 1.0. Well,
unless there isn't fresh information, then you need to go back and back and back, right?
Maybe, yes. Well, depends. So my question is how we limit how we order. if we don't limit, don't order, this is fundamental question to this query. Why do we request unlimited results set, right? This question I raise very often during consulting practice. Very often I see no limit or no order by, and this is the key question. In most cases, people say, "Oh, actually, yeah, it makes sense to have pagination here, for example." Well, pagination with Gin, yeah, it's interesting.
It's difficult, right? Yeah.
It's if we order by ID or timestamp by scalar value, it's like key set pagination works, and that's it. And Gin is just additional filtering in this case.
And we're kind of back to where we started with your original comment that it works until it doesn't. So until a certain scale, it's fine to not have these. It's fine to not have the limit and the order by, because your data set is small enough that your query response times are pretty good.
But we design for future, not only for now, right? Because so it's always worth asking yourself how much data you expect in the future, how much data you need to return with this query to your application or front end, I don't know. Do we need everything? I saw some interesting case when people intentionally decided to return everything and then do a lot of work on front end. I saw it many times actually, with guys who decided that our front end should be very thick and a lot of logic there, and it's better to cache everything. Like let's load and then work. Well, in my opinion, it's a dead end, because if your project grows, it's a dead end. You will experience poor performance. And other case was guys who decided to perform analytics with R. So they also needed to load everything and then build a B tree and so on, and kind of group by and so on was performed only in memory using R, which for me looks like, why do you do this? Do it inside your database. So and let me not to forget, when pending list is growing and to the limit, it can exceed limits, right? Or no?
Is it a soft limit or not? I'm not sure.
This is a good question. But anyway, maybe it was a bug when it exceeded. I don't remember. I remember some parts of my memory tell me that it happened in the past. I'm not sure it was a bug or no. But obviously, also select performance will be affected if pending list is huge. For example, imagine for specific filters, we are unlucky and we need to process all, we need to deal with it, and selects become slower. So
so it's 4 megabytes, right? The default.
Right, default is.
I suspect it's not too much of a penalty if you leave it at the 4 megabytes. But a tempting thing to do, might be to increase that so that you hopefully have auto vacuum kick in and do the work in the background instead of having a random insert paying the penalty.
Right.
But then once you've increased the list, then each select has to look through more pending entries, or especially towards the end, and then you're paying the price on selects as well. So I haven't seen. In fact, actually, we probably should mention there's a really good write-up about these kinds of issues by Lucas Fittel of PG Analyze, who also linked to the GitLab work.
I think Lucas does fantastic job analyzing various Postgres cases. I think that's why his company is called PG Analyze, but this is your joke, not mine.
You're stealing my jokes now.
Yes. Well, good job with PG analysis. And in GitLab's case, I was slightly involved only, and I remember that case was a few years ago. And the result was decision for specific indexes to switch off fast update, because table was huge and so on, right? Yeah, anyway.
Yeah, so switching off fast update, that means we're not using a pending list anymore, and every insert and update pays the price at the time of insertion to update the index. And I think that's a really interesting trade-off, to make each insert a bit slower, but not have to have occasional very slow ones. And I like that a lot in terms of in terms of trade-off.
Anyway, kudos to GitLab for openness as usual, because all the details are visible to public, to community, and it's super helpful for general development of Postgres and so on. And kudos to Lucas for very great analysis of this Postgres case. Good. I think we touched a little bit of some deeper waters, but not super deep. If someone wants to read internals, Igor Rogov's articles and books already great in this area.
Yeah.
And I think that's it, right? Or anything else? Good.
One last tiny tip that I think is worth. You mentioned JSONB path ops briefly. I think for most other data types, the defaults are the only operator class, but for JSONB, the default is actually JSONB ops, not JSONB path ops, and you can get a performance boost with JSONB path ops if you don't need setting up. Like if you're just using the usual JSON, the usual contains operators.
Final words. Gin is a very important index type. It's not going to disappear. It's going to be used heavily. It's one of the strengths of Postgres, like rich set of index types.
Yeah,
good.
Sure.
Okay, so thank you. See you next time.
Thanks so much, Nikolay. Catch you next week. Bye.
Bye.